In this video, we're going to talk about areas and volumes of similar solids. And this section is going to seem very similar to one of the sections in Chapter 10 when we were looking at the scale factors and areas of shapes. Okay, so we're going to use the same premise. It says here, solids are similar. So first, we have to make sure the figures that we're working with are similar. Solids are similar if corresponding parts have the same ratios. So here, let's just check. Here, I know these two shapes are similar because the radius of the tall one over the radius of the small one, I need to check to see if that ratio equals the height of the tall one over the height of the small one. And remember, we need to put them in the right spot. So if I use this as figure 1 and this is figure 2, the numbers for figure 1 I put in my numerator, and the numbers for figure 2 I put in my denominator. We have to be comparing them in the same way. And when I reduce these fractions, I get 2 equals 2. So I know these two figures are similar. Okay, so we just take the ratios of their corresponding parts and we compare them just to make sure they're the same. If they're not the same, the two objects are not similar. So then, going back to Chapter 10, we know that if we have a scale factor of two similar objects and that scale factor is A over B, we know that the ratio of their areas is A squared over B squared. Well, that holds true for surface area. The ratio of their surface areas is A squared over B squared. And then we're going to add something to this. The ratio of their volumes is A cubed over B cubed. So now we have a way of setting up a nice proportion to solve for the volume or the surface area of two similar solids. Okay, so let's walk through some examples using this. My very first two examples are, the question being asked is, are these two objects similar? Well, I know they're both pyramids in 1A and boxes in 1B, so I'm going to find their corresponding parts. So it looks like the side of the base and the side of the base. So I'm going to do, this is my first and this is my second figure. I'm going to do my first figure over my second figure. Okay, so the base is 12 over 9, and when I reduce that, it reduces by a factor of 3, so I get 4 over 3. Now I also have the height. The height of my pyramid is 27 over 18. And I know that that reduces by a factor of 9. So when I take a 9 out of 27, I get 3. When I take a 9 out of 18, I get 2. These two scale factors are not congruent. So these are not similar figures. So now let's take a look at this other one where we have boxes. So I have three sides. I'm going to call this figure 1 and this one figure 2. I have three sides and I'm going to color their sides in with different colors. I'm going to underline the numbers. I'm going to start with the smallest number first. I'm going to underline that in red and then find the smallest number on the other side, because with boxes it's really hard to tell which are corresponding sides. So I just take the smallest and the smallest. And then for the medium number, I'm going to underline in green the one in the middle. So that's 6 and 9. And then I'm going to take the largest number, 8 and 12. And I'm going to set up the proportions that way. So again, I'm going to put figure 1 over figure 2. So for the smallest, I get 4 over 6, and that reduces to 2 over 3. For the middle number, I get 6 over 9, which also reduces to 2 over 3. And for the larger number, I get 8 over 12, which also reduces to 2 over 3. So these figures are definitely similar. So their scale factor, okay, if they are similar, we can come up with a scale factor, and the scale factor is just 2 over 3. Okay, so that's how you should be doing problems 1A and 1B. So now let's take a look at 2A. All right, so it says we're given the surface area of two similar figures, and then it says find the volume of the smaller figure. So this must be the larger figure. So I'm going to put an L underneath it just so that I know it's the larger one. Which surface area is the surface area of the larger figure? Well, it is the one that has the larger surface area. So that's my larger figure, which means this one must be my smaller figure. So I'm going to create a ratio of small over large of my surface areas. And I know, according to my ratio chart up here, surface areas, their ratios are a squared over b squared. In order to find volume, I need a cubed over b cubed. So let's at least set up the surface area ratio, which I know is a squared over b squared. So that's 248 over 558. And I should reduce that ratio. And I can divide both of those by 2. So I get 124 over, let's see, 279. Okay, so how does 124 reduce? Well, I'm not sure that it actually does. So what could I do here? 16, 18, I know 3 goes into this. How many times does 3 go into this? 3 goes into 279. Let's see, 93 times. And 3 goes into 93, 31 times. Does 31, I know 3 does not go into 124, but I do know that 124 is 2 times 62, and I know that 62 is 2 times 31. So when I reduce this, I can reduce the factor of 31, and my a squared over b squared is 4 over 9. So I need a cubed over b cubed in order to solve this. So I just take the square root of 4 and 9 to get my a over b is going to be, what's the square root of 4 and the square root of 9? Well, that's going to be 2 over 3. So in order to find the volume, I need a cubed over b cubed. So a cubed over b cubed is just 2 over 3 cubed. So it's going to be 2 cubed over 3 cubed, which is going to be 8 over 27. And now I can set up my proportion. So this is my small number on top and my large number on the bottom. I don't know my volume for my small guy, but I do know my volume for my large guy. So now this is where I can just cross multiply. 8 times, and this you might need to break out your calculator, 8 times 810 is 6,480, and that is going to equal 27 times the volume of my small guy. So now when I divide by 27, I get, let's see, the volume of my small figure is, let's see, when I divide by 27, it goes in nicely, 240 inches cubed. Awesome. All right, so now we're going to do the same thing in this example here. All right, so I'm going to set up the ratio of my surface areas, and I know the ratio of my surface areas is a squared over b squared. So I'm going to do small over large again. 192 over 1728. And then I look at this and I notice if I add up all the digits, I get 12, which is divisible by 3. And then I get 1 plus 7 is 8, 10, 18, which is divisible by 3. So I can reduce this by a factor of 3. So I get 64. And for this one, I get 576. Well, I know that these are even numbers, so I get 32 when I divide by 2 over, let's see, 288. These are also even numbers, so I'm going to divide by 2 again. These are also even numbers, so I'm going to divide by 2 again and again. And I finally know that 4 goes into 36 9 times. All right, so now I need to find A over B. And remember, this is a square, whoops, what marker did I hit? This is a squared over b squared, so I need to take the square root of 1, right? Square root of 1 and square root of 9 to find a over b. I get 1 over 3. So now I need to find a cubed over b cubed. So when I cube 1, I get 1. And when I cube 3, I get 27. And this is where I can set up my nice proportion. This is my small, and this is my large. Since I'm looking for the smaller figure, I don't know the volume of the smaller figure, but I do know the volume of the larger figure. It's 4,860. So when I cross multiply, I get 4,860 equals 27 times the volume of my smaller guy. And I'm just going to divide by 27. When I divide by 27, hopefully that's a nice even number, whole number I should say. And it is. I get 180 for my volume, and I have to remember that I need to provide dimensions. 180 meters cubed for volume. I think I wrote this down wrong up here, cubed. All right. So, it says find the surface area and volume of the larger figure. We're going to try and fit this in. So I know my scale factor is A over B, and I'm given my scale factor is 1/5. So when I'm solving for surface area, I know I need A squared over B squared. So that's going to be 1 over 25. And when I'm solving for volume, I know I need A cubed over B cubed. So that's going to be 1 over 125. So let's set up the ratio or the proportion to find my surface area. So we are finding the surface area and volume of the larger figure. So the larger one's going to be underneath, surface area of large. So they must have given us the surface area of the small guy. So when I cross multiply, I get the surface area of the large guy is 20 pi times 25, which is going to be 500 pi. I'm going to do a similar thing. I'm going to set up 1 over 125 equals the volume of the large in the bottom over 15 pi. When I cross multiply, I just need to do 125